Tēnā koutou, no ototahi ahau, ko min hall ahau, kei motueka ahau e noho ana. Nō reira, tēnā koutou katoa. Welcome everyone, thanks very much for coming along and listening today. I'm wearing a few hats today. I am an architect and have been practicing for a very long time, shall we just say. And I'm also a member of EBANZ. I am on the FNZIA Sustainability Advisory Group. And I am a lecturer at Unitec, so I'm involved in teaching as well. So I won't wear all the hats, but you know, quite a few of them. If I end up sitting down, it's because I need to. And but I'm going to do my best to stay on my feet the entire time. So let's see how we go. Whoops. Not cooperating. I've been involved in architecture my whole life. The first 5 years was spent in this modernist house designed by my father. I fell asleep each night up to the age of 5 under these straw ceiling panels. They were Stramit panels that were manufactured in Australia and imported to New Zealand in the 1950s. I discovered this after my father had died, so I couldn't really ask him any more about it. But I think that, you know, perhaps they had an influence in my later career. Also, another thing that may have influenced me is that we used to go and visit my Auntie Margot, who lived in a rammed earth house that her father built in 1925. So I used to go and visit there a lot. So I've been thinking about where my interest comes from, and I think that it might have been sort of embedded in me from a very young age. And so it's sort of set off this, I guess I've always wanted to be involved in an architecture that is appropriate to place, that wastes nothing, and that really engages with te tau, the environment, in a respectful way. You know, I think that architects should be kaitiaki. And this pursuit has been done through a number of built projects, and then I got to a point in my career where I really felt this is no good, you know, the occasional project at a time. It would be much better to be involved in teaching and trying to influence young architects. And so hopefully there's a couple in the room I might have had slight influence on. I'm not going to talk much about my built projects today, bar one, but I have designed and had built about 9 adobe brick houses and 3 ones in straw. And then more latterly, I have switched my focus. I probably am going to sit down because it's just going to make me more comfortable. In my research, I've been really looking at waste materials. And this began in 2012 when I did a survey of 130 earth and straw houses in the Nelson Tasman district. And I was looking at how they performed and what their potential might be. And so since then, I've been really looking into how to use this resource here. This is Canterbury after the grain harvest. This is just a few hectares of the many that go up in smoke with the straw that is left behind. And so my research was involved in looking at how can we upscale this, and prefabrication is the obvious answer. And I'm really rapt that Ben is here with his product to talk about that. So all within this time it's sort of like we've been on a parallel journey, and it gives me a lot of pleasure to see that it is actually happening here. EBANZ, so it should come as no surprise that I'm a member of EBANZ. I've been involved in the committee that developed the Earth Building Standards for the 1998 ones, the review in 2020, and then the more recent ones in 2024. These are Alan's copies here, anyone who wants to have a look, but I will talk about that a little bit through this presentation. So what's EBANZ? EBANZ was founded in the 1980s by architect Graham North, engineer Tace Dripstein, and potter Yvonne Rust up in Whangarei. And EBANZ is a network group consisting of architects, engineers, builders, academics, homeowners, and the general public, people who want to build a house for themselves. And so the focus of EBANZ is promoting the art and science of earth and natural buildings. So we still call it EBANZ, Earth Building Association of New Zealand, but it encompasses looking at straw, looking at hemp, looking at basically natural building materials in general. A quick reminder about why this is important. This slide is from the introductory lecture in the elective course that I teach at Unitec as part of the Bachelor of Architectural Studies. The course is called Resource Matters, Materials for Climate Change. And this is, in the first slide, I ask these questions and I hopefully answer them. So I just want to flick here straight to the third question. Why should architects care and what should they do? 40% of all greenhouse gas emissions globally result from the construction and operation of the built environment, and in Aotearoa that figure is about 20%. Two kinds of energy, operational emissions and embodied energy. And I think everyone knows what those mean, so I won't go into it, but I guess it's the embodied emissions that we are really focusing on now, because over the past sort of 20 years or so, we have really upped the game in terms of operational energy and insulation requirements, etc. So globally, it is estimated that embodied emissions make up around 20% of the total built environment emissions, so about a fifth. So I guess all we can assume is it's going to be something similar here. And then if you add to this fact, the fact that 50% of all waste in Aotearoa comes from construction and demolition. It's a massive amount that leaves our building sites kind of every day, really. So a key thing that we're sort of attempting to provide knowledge to help answer this question is that the decisions made at the beginning of a project really play a huge part in the amount of waste that is generated through the process, and it really influences the carbon footprint. This is an approach that is, once again, from my lecture series, that is suggested in Architecture by Architecture 2030. I don't know if you're familiar with that website. Architecture 2030 is from the United States, and it's really worth checking out. But basically, this approach is talking about adopting the principles of reuse, number one, reduce, number two, so reduce perhaps the amount that we're building and also the amount of materials we're using, and then to sequester, and sequester carbon by using carbon sequestering materials. This image here I think is really helpful. This is from MB. I don't know, has anyone seen this in your program? Yep, thank you, one person. Oh, cool. And this really correlates the various strategies for carbon reduction with the decision-making process. So you can see along the bottom it's got the decision-making process, which is about planning, design, then detailed design, etc., right through. So what we're really looking at the beginning is really questioning whether you need this building at all. Then it's more talking about, can you use parts of a building at least, building less, and so on. So building smarter, building efficiently, but it's just really sort of, asking some difficult questions up front of your clients, I would say, as an architect. You've got to make a living, I accept that. I just add, actually, the reason that I went into teaching was that I felt like I had enough buildings built. I'm very fortunate I had a lot of projects built, but I wasn't doing the kind of projects that I really wanted to be doing. And so I thought, I can have more impact if I'm involved in teaching the next generation of architects. So that's what's driven me to be doing what I'm doing. I just thought that perhaps this little building, which is a straw bale sleep out, which we began building probably in about 1998 on the property that I used to live in Regenerative, when building with straw bale was really quite new. But we made no compromises with the technology and the techniques that were available to us at that time. So the building, its major structure is from recycled hardwood timbers. So there were telegraph transmission poles. They're dug 1,200 mils into the ground, so they act as cantilever. Then we've used a concrete slab with terracotta roof tile offcuts that were made into a mosaic floor that you can sort of see, hopefully in that bottom image there. And so forth. The walls were made of straw bale, and at that time, we didn't know of anyone who could do earth plasters at that point. So we were building in the way that straw bale building was done at that time predominantly, which was that it has chicken mesh on both sides of the building, which is sort of stitched together. And then we used a cement lime plaster on the outside and also a cement lime plaster on the inside, but we used a white cement and we used sand from a local stream, so we got sort of quite cool colour. And on the outside we painted it with Kāhui granitol paint. I don't know if anyone's used that. It's a silicate paint. It lasts forever. This building's still never been painted again. Hart macrocarpa, Hart Douglas fir. We used Onduline as a roofing product, which I wouldn't recommend anyone do now. But at the time, this was very exciting. That was a bituminized recycled cardboard, but actually it can't handle our sun. So it's been replaced with a colour steel roof. And things like we used copper spouting. I'd be looking for some recycled stuff. But we didn't have any spouting at all on the back side of the building. We had the roof just came down quite low, dripping into a gravel drain. So, and we wouldn't be doing a concrete slab if we were doing this now. We'd be doing an earth floor. So it's just, it was an attempt. And I still think it's probably a lot better than many other buildings down the road, for instance. So we'll see. Returning to these questions, what does low carbon mean? And basically looking at what low carbon materials are. So basically they low or no CO2 emissions, capacity to sequester carbon, and they are renewable. So not everyone has all those three attributes, but that's what you're aiming for. Low carbon materials fall generally into two categories. So there's geomorphic, which is earth and stone, and then there is biomorphic, which are more the bio-based ones like timber, straw, hemp, and more. And so together they are often simply called natural materials. Despite that being a bit problematic in some ways, because asbestos is a natural material, but we won't go there. Really important to acknowledge that Māori have used indigenous materials, raupo, harakeke, toi, for building with for generations. They also used earth as a binder for many of those materials, and earthen floors, and also mounding up against the walls of houses for insulation. But they weren't using earth in a structural manner. That came with the settlers here. Many low carbon materials are actually considered waste and treated as such. So here I'm referring sort of quite specifically to straw. I'm referring to the hemp hurd, which is basically the stalk of the hemp plant. And so whilst the leaves, the fibres, the oils, they're all used, if we weren't building with hempcrete, we'd be wasting that as well. Also, earth. I mean, how many times do you see truckloads full of clay around Auckland, leaving site and going off somewhere to be dumped? Hopefully Alan Drayton's diverted them and they've come via one of his jobs and he's going to turn them into a beautiful clay. But just this kind of thing that we are wasting a lot. And the other thing is timber. someone was asking me just before we started talking about, how can we be recycling and reusing timber more? And I think that's something that we really need to address, because we are wasting an enormous amount of offcuts, and the treated ones are a real problem. So yeah, that's a whole kind of field of its own. The other thing about timber, though, that some of the materials that you can build out of, some of the earthen materials where we're making a lighter earth mix, are using things that are considered waste, say, from timber milling. So there's wood shavings, there's bark, there's paper pulp as well, and there's sawdust, and the list goes on. Anything kind of fairly lightweight and fluffy is going to be pretty handy. Why are these materials the answer? Basically, occupant health. Clay is a wonderful humidity regulator within buildings. We're looking also at materials that don't have any VOCs or irritants. Low carbon, we've already talked about that. And often these materials can be quite affordable if you're building yourself, or if you're involved in the build in a long way, but there is the potential to upscale for locally appropriate production. And I think that whole thing about upscaling is where we're trying to move the Earth Building Association, for instance, which has been really geared at enabling people to do their own thing, to build their own houses, or with a skilled builder. It's quite geared for that, but it also now wants to acknowledge that we really need to upscale if we're going to make a difference. So a bit of a plug for the Earth Building Standards. These have been revised and reflect current best practice engineering requirements, and they're also importantly involving more lightweight insulating techniques. So NZS 4097 is for engineers. A few engineers in the room, Eddie. But I don't look at that very much. But I do look at this one, materials and construction for earth building. This is 4298. And then 4299 is kind of the NZS 3604 of the earth building. And it allows you to build a simple dwelling without needing engineering design. It also has in the back 3 appendices. One of them is for using adobe brick as a veneer, so getting the thermal mass inside a building, which is, I've done that in a number of buildings I've designed, and it's really quite a good thing to do. You want your thermal mass within your building. And then it has an appendix which is about straw bale construction, and one that is about the light earth method. So I will just explain a little bit what those things are in a minute. But essentially, the key ingredients that we're talking about that are covered in the Earth Building Standards are a fibre of a number of varieties, a binder, and aggregates. So if you just want to be very simplistic about it, that's what we're doing. Just should mention here in terms of the sort of hemp world that Doug Sturrock from up north has come up with a product called GeoBind for hemp, which is trying to come up with a binder that does not use cement. That has always been a little bit of a sort of negative that purists would have about hempcrete, is that it still involves cement. Cement is involved in most earth buildings as well, it's fair to say, at least for the foundations, but it's just trying to keep it to a minimum. This gives a good overview of the methods that are covered in the standards, and with their sort of corresponding thermal qualities. So from going left to right, you've got straw bale, which is lightweight, not so strong on the thermal mass, but it still has some by the time it's got its plasters on it. Very good insulation values. And then you go through and you've got light earth method and hempcrete, which are somewhere in the middle, low density earth bricks. adobe and cob, and then rammed earth and pressed bricks, which are the densest ones. So Alan's going to talk more about them. But yeah, that's probably what I've got to say about that. I'm hoping that these slides will be available to everybody afterwards, because I have printed off some more of a definition here. This is from the definitions in the front of the earth building standards. I mean, what I keep finding is people say, oh, have you seen that cob house down the road or whatever? It turns out to be that it's rammed earth. Or they tell me, have I seen a rammed earth house somewhere, and it's actually out of adobe brick. So it's actually really trying to get, this is something that would be great if you guys who are involved in the design of buildings got more of an understanding about what is what. So the traditional adobe bricks or sun-dried bricks, they are, I'm not going to go through them all, but it's basically a puddled mix of earth, which has got a high clay content, some silt, and then it's usually got some kind of a mixture of straw in it as well as sand, and that is poured into a mould, and when it can hold itself, the mould's lifted off and it's air dried. So we go through and we have various sort of, that's one end of the agenda. They are actually just in alphabetical order rather than any particular order otherwise. But and also just generally stabilised when you're talking about earth generally means that it's got cement in it. But there's been a lot of work gone into low density earth lately. How am I going for time, by the way, Jazz? All right? Yeah. I'm probably about 3/4 of the way through. Okay. All right. So you can look at that one later. NZS 4298, this has got a lot of fun stuff in there. This is about materials and workmanship. And a really good part of 4298 are the tests at the back. And they've been developed over time, and they've been developed specifically so that you don't have to go to an expensive lab to get your earthen material tested. You can actually do it at home, or you can do it at Alan's place, which these photos are here. This is the flexural tensile strength. So you make a mixture of a variety of different bricks, and you test them for various things. So you're going to test them for water penetration, and you're going to test them for different kinds of strength. And did anybody see Grand Designs and the rammed earth house last week or whatever? Yeah. So that was showing those builders there were using this test as well. So it's it really can get used. And so that's, it's fair to say that the members on the committee of the Earth Building Standards were really still wanting to make sure that this still enabled owner builders, but it's also aimed at helping anyone who wants to be involved in designing earth buildings. Don't think I need to say anything more there. Probably a key thing here is, how come I've only got, oh there we go. Structural light adobe, SLA, and there's also structural light cob. So over time, and it sort of came about as a response to not being able to satisfy the old H1 with regular heavyweight earth bricks. And so coming up with the idea of how can we make them perform better and insulate them more. So this work was done, I don't know, 10, 15 years ago began, of making a whole lot of earth bricks using different materials. Some of the key ingredients have been paper pulp and wood shavings and sawdust that's gone in. I know Alan's been involved in trialling different ones as well. But that is really kind of where we need to be going. If we're going to be using earth in this country, we need to have it more lightweight. It's also much easier on the body when you're handling these lighter weight bricks. But really now with, before anybody asks me about H1, I'll just say that generally for an earth building, you're better off to do some thermal modelling to figure out what's required, and you would always be trying to, you'd be beefing up the insulation in the roof, which you have to do anyway. So that's been something that we have grappled with over the years. And then one of the other things that's pretty key in these standards is the use of internal adobe veneer. In these two projects here, the one at Taniatua, I'm sure that many of you are familiar with, the Jasmax building. I've got another slide of it a little bit further on, but in that case, a whole lot of bricks were made using earth from different parts of the iwi's lands, and in different spaces to be using them. And the one on the left is an architectural designer in Nelson, Mark Fielding, who's come up with this solar abode where he's been doing this sort of using adobe inside buildings instead of on the exterior. But we actually really needed to test this, because if you're going to come in and bring a heavyweight brick inside a building and hang it off an internal wall, you're kind of really messing with the overall structure. So we needed to feel sure that it was going to work. So a whole lot of testing was done at the Solid Earth Yard in Nelson, led by Hugh Morris from Auckland University, where basically they had a hinged foundation, they built an adobe veneer wall on top, they shook the hell out of it with that digger, and worked, engineers do testing until things break, those cracks aren't necessarily bad, they're informative. And so what that was telling us was how well we needed to fix these bricks to the timber framing. And this is what was come up with on the right-hand side there. You can see some of the drawings from NZS 4299, which are in the Appendix F, which is about veneer. And then on this image here is of the team making bricks down at Taniatua for the Tūhoi headquarters. Just to give you a little more of a taste of what's going on in the earth building standards, there's a lot of diagrams, details. Here, this is from Appendix D, the light earth method on the left, where there's various ways that you can use light earth, but it's often used within a sort of 3604 type timber frame, and the mixture is tamped within boxing in the middle. And then on the right is a detail from the straw bale appendix as well. So this is meant to be an introduction, and I think it's it's giving councils, it's giving homeowners, it's giving engineers who haven't done this before, it's giving architects some tools to not be afraid to give these materials a go. And particularly if a client comes to you and says, I would really like to try doing this, then that's your best client, not the ones you've tried to convince to build out of straw or something, because then if it fails, it's going to be your fault. But look for those clients who come to you first. I could just about finish there. I've got some, here, this is just sort of summing up strategies about starting new designs, etc. But I kind of think there's too many words on these slides, basically. But we can have it. But just point you to this tool. Whoops. One here, this is from Rachel. This is the construction materials pyramid. And there is actually the website down the bottom here, but it's basically going from the highest embodied carbon content at the top of the pyramid down to the lowest at the bottom, and pretty well all the materials I've just been talking about are in those bottom two tiers down there. So, thanks for listening, and I'd like to encourage you all to sign up for this year's EBANZ conference, which is going to be in Otaki. This will give you the opportunity to talk to experts, see houses, and also to visit Te Wānanga o Rokawa, which was designed by this year's gold medal winners for the Institute, Tennant Brown. And we have a kind of like a professionals day on the Friday, and then we have the house tours and other lectures through the weekend. It's a fantastic way of networking and finding out about stuff. So thank you very much. I think I'm done. Thanks.
Did we have any quick questions for Min?
Thank you, Min. That was super helpful and informative. Very good overview, because I don't know much about this at all. I'm just really interested to know what the barriers and challenges are to building it in terms of like getting across the line for building consents, building consent authorities, variations around the country, etc. Is there, what are the biggest parts of the build that are the hardest to achieve a consent for?
I guess it's collating the information for the building consent, but these, on the Earth Building Standards Committee, we've always got 1 or 2 building inspectors who've been on that committee the entire time. And their input has been fantastic, because they say, oh look, if I was looking at this detail, I wouldn't be happy with that. I'd be wanting to know how you're dealing with, how does this satisfy B1 or, Q7, whatever. So that has been the biggest challenge. I'd say, we don't have enough experts across the board who are familiar with it. But consenting is, these standards have made a big difference, and we're getting that feedback from around the country. Yeah.
One sort of supplementary comment. I can tell you that the 50% of all waste in New Zealand is construction demolition waste. That's about to be changed. So there'll be a report coming out from the Ministry for the Environment soon.
Cool. Okay.
Thanks, Min.